All right, let's go ahead and start by solving this equation. And to solve it, I'm going to use some principles of equality. First thing I notice is that there's no distribution because there's no parentheses. And then there's no like terms that I can combine on either side of the equal sign. So I'm going to go straight into principles of equality. I've got x's on both sides of the equal sign, so I'm going to put all of my x's on the left, and I'll put all the numbers on the right. Now we just check to see if it belongs, right? So 4, for example, does not have an x, but it's on the x side of things, so it has to be zeroed out. So I'm just going to subtract 4 there. If I do it to one side, I must do it to the other side also. So from left to right, 4 minus 4 zeroes out as planned. I can now drop again. This is not 2x, it's negative 2x. The arrow always brings down the equal sign, but the 8x also can just drop because we didn't do anything with it either. And then 16 minus 4 ends up being positive 12. You can check your calculator for that. Now we'll need another principle of equality, which is going to bring the equal sign down once again. But I notice that I've got an 8x on the number side of things. Again, we already checked the negative 2x. It's the x. It's on the x side of things, so that's okay. But the 8x is on the number side, so that can't be there, meaning that I must zero it out. So I'm going to subtract 8x's from both sides. Again, I've done it on the right, so I must do it on the left as well. So how many x's does that give me on the left? Negative 2x's minus 8x's would be negative 10x's. The 8x in black zeroes out with the purple minus 8x, and then we can drop this positive 12. Next up, what we're going to do is we're going to force that coefficient of x to be a phantom 1. We want this to be a 1x, not negative 10x. So the coefficient being negative 10, how do we make it a 1? We simply take it and divide it by itself. So negative 10 divided by negative 10 is 1. But if I do it to one side, I must do it to the other side. Now here, if you put this into the calculator, it's going to give you, I believe, negative 1.2. But I would prefer the fraction on this one, which should be negative 6/5. Again, when you get the decimal on this from the calculator, you just push math enter, enter, and that will give you a true statement. Okay, now the last thing I'm going to do is I'm going to take this negative 6/5, replace it with the x's, and make sure that I get a true statement from my calculator. On the left side, it gave me 6.4. On the right side, it gave me 6.4, which as a fraction would have been 32/5. It doesn't matter. It's the same thing on both sides, which means we have, in fact, found the solution. All right, there's our objective for the day. So take a minute and copy these down. I can solve a system of equations with graphs. I can write equations from word problems. I can change standard form to slope-intercept form. Now remember, this is a video, so if you feel like you understand how to do these problems without having to go over all the problems in the video, skip some of them, all right? Try the homework, come back to the video if you need it. Some of you may prefer to just watch the full video, and that's fine too, but the truth is you can kind of do the homework at the same time as you watch the video, and hopefully that helps. So when we solve a system by graphing, what we're looking to do is put two lines on a graph. And when we do that, what we're looking for is the intersecting point of the two lines, because that intersecting point becomes the solution of the system. So a system is just saying you have two or more equations that you're going to put on a graph. Right now, we're just going to put two of them. So for example, maybe you end up with something like this red line, and maybe you end up with something like this, let's see, this purple line. Now, if it were asking, because you graph these from their equations, it's saying, well, if you wanted the solution to that system, and I couldn't tell you what the exact value is, but it would be this point right here. This point is the solution. Okay? And again, whatever that ordered pair would be, just to estimate maybe 3.25 and 2.5 maybe, that would be the solution as an ordered pair. Now, the other thing that this has to be true for these two lines is that the solution has to be able to make both equations true. So if we have the equations for these, if we had the red equation, we would say this point, we could take that ordered pair and replace it into the red equation and say, all right, does it make it true? And it needs to. Same with the purple equation. If the equation that gave us the purple line we could take this ordered pair and replace it into that equation, and it needs to make it true. So when we get both equations, because we're going to be looking at equations to graph, we need to test that ordered pair in those equations to make sure it is true. And that's what this slide is asking us right here. It's saying, here's an ordered pair, 8, 1. Will it make these two equations true? It needs to make both of them true, not just one. So if one is true, we still need to check the other one. Okay, so let's take that first equation. X plus y equals 7. And in the ordered pair, they've given us an x value that's 8. So I can take the x and replace it with 8. And it says that its corresponding y value is 1. So I take my y from there, I replace it with 1. And what I notice here is that I'm checking for truthfulness, right? So I put a question mark over the equal sign, but I notice that 8 plus 1 would be 9. It does not equal 7. This right here is a false statement. So about that ordered pair, we would say, at least even just for this equation right here, it makes it false, okay? So is it a solution? I guess we could just say no, but false or no, I guess probably around the same thing. Now, just to emphasize what we're doing here, because it made that first equation false, the second equation, y equals 1/4 x minus 3, if you were to replace the x with 8, and if you were to replace the y with 1, then you would have the equation 1 equals 1/4 times the 8 minus 3. And you could have checked this one to see if it's true. And so I just put this in the calculator right here, 1/4 times 8 minus 3. And that ends up being 2 minus 3, which would have ended up being -2. So this one also would have been false. Now, it could have been true. It was fairly close to being true. But if it were true, this one were true, and this one were still false, this one were true and this one was false, then the overall thing would still be false, okay? So both of them have to be true in order for the ordered pair to be on the line. Now again, to emphasize what we're looking at on that last one, if I were to graph these two lines, and again, I'm just kind of doing this offhand, you got your x and y axis. The first equation, which I guess I will do in red right there, that's x plus y equals 7. It would have given us a line something like this. The second equation, 1/4 x minus 3, I'll do this one in purple. Again, I'm just doing this offhand, but I'm trying to show what happened there, is we would have had something, maybe something like this, okay? Now, about these, the ordered pair that we had up here, the 8, 1, would have been, probably around right here, okay? So, 8, 1, this ordered pair, 8, 1, since it was false, it didn't make the top equation true, which means it's not actually on the line. But it also didn't make the bottom one true as well, the purple one. So it made that purple line. It's not actually on that line either. Now, if it were true for one and the other, then it would be on one line, but not the other. What we need is it for the ordered pair to be true for both equations. All right, let's take this ordered pair and see if it is a solution to the system. So I'm going to start with this first equation, the one on the top there, y equals -2x minus 3. And again, we have an x value that's -3, so let's take the x, replace it with -3. That's a -3. And then our corresponding y value is showing us +3. So I replace the y with 3. And then I'm putting a question mark over my equal sign because I don't know if this is true or not. But I'm going to put it in the calculator and let's see what happens. Of course, I don't really need to put the 3 in the calculator, but we should get 3 equals. And then I just plugged all this into my calculator right here. And when I do, I get 3. Now 3 does equal 3, that's true. So as of right now, all we know is that this ordered pair is on this line, if it were a graph. Okay, so again, if I was to look at an actual graph here, we'll pretend like my lines are very straight and this looks pretty, but you'd end up with a graph that looks something like this one. So we'll say that's our red line right there, okay? But -3, 3, this ordered pair would be on the line about right here. And again, I'm just estimating, but that would be the ordered pair, -3, 3. We'll call it that. Okay, so that's that one. Next, we take our next ordered pair, y equals 1/3 x plus 4. So again, I'm going to rewrite this plus 4, but up here we're showing an x value that's -3, so I replace the x with -3. I see a y value that's just a regular 3, so I replace that with 3. And I'm checking to see if this one also is true. If it is, then the line should go through this point. So let's see. All right, so again, nothing to do with the 3, but on the right side, I can put all this stuff in my calculator, and when I do, I get 3. Now again, 3 does equal 3, that is true. So what that means is that since both of them are true, we can right now, if we wanted to, say, is this ordered pair a solution to the system? You can say yes, you can say true, it doesn't really matter, but I'm going to put yes. But again, on the graph, here's what this means. It means that if I were to graph this line, it would look something like this one in purple. So we'll call that the equation there, our purple equation, the purple line. But again, it is going through the exact ordered pair of -3, 3. So because this ordered pair is on this line, but it is also on this line, it does represent the solution to this system of equations. Now, in the future, instead of them giving us a point, what's going to happen is we've got to put these two lines on a graph, kind of like I did, and then we have to figure out where this ordered pair is. So that's what we'll be doing on this one. Now, I'm going to do this. You can use the slope and the y-intercept on these to graph. I'm not going to do that. What I'm going to do is I'm going to use a table, okay? So I'm going to have some x and y values, and then we're going to see what values we can come out with. And as usual, I'm going to start with an x value that's 0. And yeah, we're going to call this our red equation there. I'm going to use this first one, y equals 3/2 x minus 4. And I'm going to put the x value in as 0, because that's the value that I've chosen. So I'll rewrite the equation. Y equals 3/2 x minus 4, but we're replacing the x with 0, and we're trying to figure out what this ordered pair would be, the corresponding y value. So to go back, this is like the function machine. Here's my function. Now I'm saying I'm going to put 0 into the function. What's going to come out? Well, when I put this into my function, I get a corresponding y value that is -4. How did I get that? I just put it into the calculator, okay? So I did 3 divided by 2, parentheses 0 minus 4, and then it gives me this answer. So I get the ordered pair 0, -4. Now you can put that on the graph, but I'm expecting to put several points on this graph. So let's see what happens next. I'm going to choose an x value that's 2. Now why did I skip 1? It's because the denominator of my coefficient of x is 3/2. The denominator is 2. So I need multiples of 2 to put into x in order to get whole values of y. So here's what happens. Okay, we got our equation, y equals 3/2 x minus 4. We just chose an x value that is 2. Okay, and now what comes out? Well, I put in 2. What comes out of my function machine? I get -1. Okay, now again, that's an ordered pair. It will fit on the graph, and that's good. But I probably need more points. In fact, I'm probably expecting several more points here. Okay, so let's go to an x value that's 4 here and see what happens. Okay, so y equals 3/2 x minus 4, but I'm going to replace the x with 4, and that's what I'm putting into my function machine. What comes out? Well, when I put this into the machine, I get a 2 out, so this would be the ordered pair for 2. Now you see, we're just using the same function as we go. Remember, there is a shortcut for this, but I'm going to hold off on that, just to show you how tedious this can be if you don't know how to use the right tools. So I still have y equals a 3/2 x minus 4, and the next value I choose, I'm going to choose a 6, because it is a multiple of 2. So what happens when I take that x and replace it with 6? Then I get a y value that is 5. Now that's pretty good. And again, that's another ordered pair. I assume I possibly could need some negatives on this, so I'm actually going to throw in a -2 right here. So again, I'd have y equals 3/2 x minus 4, but we've just chosen to replace the x with -2. Okay, that's a -2. So what happens now? I get negative 7. All right, that's a nice ordered pair. I can put that on the graph. What happens if I make the x a negative 4 then? All right, let's see what happens. So the y equals 3/2 x minus 4, but we're replacing the x with a negative 4. Okay, when I do that, I get negative 10. And that would take me all the way to the edge of the graph. So let's see what happens. These are all ordered pairs in my table here that I need to put onto the graph. So I'm going to start with 0, negative 4. That's going to give me that point that I've already put on the graph. Then I have 2, negative 1 here. Then I have 4, 2, which would be here. Then I have 6 and 5, which is, I think I got that right. Now that's all the points that I have there. And then I've got the negatives, right? So negative 2, negative 7 would be here. And then negative 4, negative 10 here. So that takes me to the edge of the graph. If I wanted to, if you had gone into your calculator and you said, you know what happens if I replace the x with 8? Let's see, then you would have had 4, 12, an 8, 8. Okay, and I think that's as much as we can fit on this graph in that direction. Now I skipped the math there, but again, you're just plugging those values in, and you see how you can kind of skip this stuff if you have this stair-step method down with the y-intercept and the slopes. But we're skipping that because it seemed like a lot of students struggle with it. So you can just do in and out. You put in values with your x's, you see what comes out with your y's. Now before I connect those dots, which would create a red line for us, I'm going to take this other equation, which we will call our purple equation, and I'm going to do the same exact thing. So I've got my x's, and I've got my y's, and I'm expecting to find many ordered pairs to put in here. But once again, I'm going to start with an x value that's 0, so that's a y equals negative 1/3 x plus 7, and then I replace the x with 0. And I put this into the calculator, which when I do, I get an ordered pair of 0, 7. Okay, so that's our first ordered pair. You could put that on the graph now. I'm going to wait till I get a bunch of ordered pairs. And again, for my next x, I'm going to skip 1 and 2 and go straight to 3. Again, the reason that is because I have a denominator of 3. In fact, I'm telling you the next value I'm going to choose is it's going to be 6. Because what I'm doing is I'm choosing x values that are multiples of 3. 3, 6, 9. I wouldn't go as high as 12 because that goes off the graph. But I could use the negatives of these values too. So let's go back to the equation. Y equals negative 1/3 x plus 7. But I'm replacing the x now with 3. And again, that is in order to make that ordered pair a full value. So that's going to be 6. So again, that would be the ordered pair 3, 6. And we'll try the next one. Let's see what happens when we put an x value rather, is in as 6. So y equals negative 1/3 x plus 7, but now we're going to replace the x there with 6. So if I put in 6 into this function, it appears that I get a 5 out. So that's the ordered pair, 6, 5. Okay, well, I can do more points. You could do 9, but I'm gonna, you know what? I'll do 9 actually. Okay, so that's gonna be y equals negative 1/3 x plus 7. We've chosen an x value rather. That's 9. Okay, so that's y equals negative 1/3 times 9 plus 7. If I put 9 into this function, it appears that I get 4 out. Now, it is creating a pattern, and some of you may have noticed that. As I've gone up by 3 for my x's, my y's have gone down by 1, which is representative of the slope. But whether we notice that or not, I'm going to switch gears and go back into the negatives and say, what happens if I make the x value negative 3? Well, it's still y equals negative 1/3 x plus 7, but if I replace that x with a negative 3, then I get a corresponding y value that would be 8. Now that does fit on the graph. And without doing the work, I'm just going to show you if you put in negative 6, then it appears that you would get 9. And so negative 9 would be 10. So let's get these points on the graph. Let's see what happens. Okay, so I'm going to start at the top of my table here. All these ordered pairs I'm going to put on the graph. I'm going to start with 0, 7, which is here. Then the x is 3, the y is 6, up here. Then we have the x is 6 and the y is 5. There's already a red dot there, and that's good to see because now I can see where the two lines will intersect. But before I draw the lines again, I'm gonna put the other points on there. So I got 9, 4, which would be here. Then I had negative 3, 8, which was here. And then negative 6, 9. And again, that shows that you would have had, if you had done the work for that, you would have had negative 9, 10. So at this point, I can put the graphs on the line, which I will do. There's my purple line, and then we can do the red line as well. Boom. Okay, and that's not perfect, but it's okay. I'll put some arrows on my lines, both lines, to show that they are actually lines, but again, we can see the intersection of the two lines here at this green ordered pair, which is showing as the ordered pair 6, 5. Okay, because again, you can follow that line down to 6. That's our x value, and then follow the line over here to the y number line, which is 5. Now, did we really need that? No, we didn't, because as it turns out, we saw that we had 6, 5 here in our red equation, but we also saw that it matched here in the purple equation. So since we had those two matching ordered pairs, technically we didn't even need the graph. We could have said, look, my tables here show that we have the same point on the two lines. So 6, 5 would not only make the red line true, but the purple one, but that's the only point that would make these two true, which again proves that that is the point of intersection for the two lines. Okay, before I do these, take a minute. You may need to pause the video, but try these two equations. See if you can find the solution, and then we'll go over it together. Okay, 1 minute. All right, if you still need more time, please pause the video, but I'm going to proceed as though you are ready. So, again, I'm going to do this with inputs and outputs, x's and y's. And then we'll find corresponding values as we go. And the nice thing about this first equation, which I guess I'm going to call my red equation there, is that this one, if I put in x values, if I do inputs, I get direct outputs. For this one, it's going to be a little different. We'll show that in a second. But first, I also see on this one that I have a denominator for my x, which is 3. What I need to do is I need to choose values of x that are multiples of 3. So I'm into the machine. I need to put in multiples of 3 because then that's going to give me nice ordered pairs. So here's what I'm talking about. I'm choosing values of x that are multiples of 3, like 0, 3, 6, and I'll stop at 9. See how that does, okay? So I'm planning on choosing these values because they're multiples of 3 because it's going to work with that denominator as I multiply. So from this, then, we would have y equals 1/3 x plus 3. But what we're going to do is we're going to replace that x with the x value we've chosen, which is 0. And that will give me a corresponding y value of 3. So that's the ordered pair, 0, 3. We'll put that on the graph later. But first, let's proceed with these other values. So if I replace y equals 1/3 x plus 3. Again, I'm choosing to put an x value in at 3. That would give me a corresponding y value of 4. Okay, so that's the ordered pair 3, 4. Same with 6. Y equals 1/3 x plus 3. But now we're going to replace the x with 6. And if I do, that would give me a corresponding y value that's 5. Now, you can see as I go down this table that we see a pattern. As I improve the x's by 3, the y's are going up by 1, which is actually demonstrated in the slope. Now, I chose an x value that's 9. I wouldn't go to 12 because that would take me off the graph for my x values. The x value 12 does not appear on the x number line. So I take my equation, y equals 1/3 x plus 3, and I replace the x with 9. So this will give me a corresponding y value of 6, which we pretty much expected if you saw this pattern as it goes up by 1 for my y's, okay? Now those points you could put on the graph, but I'm going to show some negatives as well, but again, I need them to be multiples of 3. So I'm going to do -3 and 6. My equation, y equals 1/3 x plus 3. But now my x I've chosen to be a -3. That would give me a corresponding y value of 2. So let's see what happens with 6. Y equals 1/3 x plus 3. But replace the x with -6. That gives us a y value of -1. There we go. So that's a lot of ordered pairs. Let's see if that's enough to find the solution to the graph. Let's put them all on there. I'm going to start at the top, 0, 3, then 3, 4, and then move my way down on the table. So we have 0, 3, that's here. 3, 4, here. 6, 5, here. And then we had 9, 6, here. Okay, so there's our points. Of course, we also had -3, 2, and also -6, 1. If you continued, you would have had the ordered pair -9, 0. Now, I know that because of my stair-step patterns, which I'm seeing, but not everyone would notice that, and that's okay if you don't. But let's see what happens with this other equation. So, inputs, outputs, x's and y's. Let's see what happens when we do this. Okay, now this one, you may have to guess and test a little bit with these x's and y's. I guess what I would do is I would probably start with an x value that is 0 still, because 0 is a very nice number to work with. Okay, so for our equation, 5x plus 3y equals 9. Well, we're going to replace the x with 0, and we've seen this happen before, where that's just going to make that term 0, and then all I'm doing is solving the rest of that equation. So 3y, I'd have to divide both sides by 3. That gives me a corresponding y value of 3. So I end up with the ordered pair 0, 3. Now, some of you noticed something with that ordered pair. I'm going to skip it, come back to it, because we probably need some other ordered pairs to work with here. Now, I'm choosing values of x, and then finding corresponding y values. So I'm putting in, again, my input is x, my output is y. What I'm going to do is I'm going to use multiples of 3 because this coefficient of y is a 3, meaning, now let's see what happens if I replace the x with 3. Let's just see what happens. Okay, so that'd be 5x plus 3y equals 9. And then we're replacing the x with 3. Okay, so that'd be 15 plus 3y equals 9. If I solve this, I'd have to subtract 15 from both sides. Then I got 3y equals -6. Divide both sides by 3, and y equals -2. So I end up with a nice ordered pair of 3, -2, and that's good. But it was some work, right? There was some solving equations involved there with some principles of equality. So as I move down, and I've got to skip a spot there for some space, again, I just want a multiple of 3, and let's see what happens here. So that would have been 5x plus 3y equals 9, but we're choosing to replace the x with 6. We have chosen that value. Okay, so that'd be 30 plus 3y equals 9. I'd have to subtract 30 from both sides, which seems kind of large, but it's going to be 3y equals -21. And now dividing both sides by 3 gives me a corresponding y value of -7. So it does work. I can put that on the graph. Now, because I'm running out of space, I'm going to switch directions and just see what happens if I put in a -3 into the equation. So that would be 5x plus 3y equals 9, but we're choosing to replace the x with -3. Okay, so that'd be -15 plus 3y equals 9. Add 15 to both sides. So, see if I can fit this on there. 3y equals 24. And then I divide both sides by 3 to get a corresponding y value that's 8. So that's going to work. That's a negative 3, 8. And so here's what happens. Let's get all these points on the graph, as many as we can, right? We got the 4. And now I have the first ordered pair at 0, 3, which is already on the graph in red. And that's demonstrating our intersection. We'll come back to that. Let's see, we got 3, negative 2, which would be here. Then we got 6, negative 7, way down here. We also had the ordered pair, negative 3, 8. So that looks like that's all we could have fit on the graph as well. But we do have our point of intersection. Let's get those lines on the graph first. Okay, so we'll start with the purple one, because that's what I got pulled up. But we end up with, if I can do this a little better. Yeah, something like this. Okay, there's my arrows. There's my purple line. Again, is it perfect? No. But when I get the red line on here, we'll demonstrate where the ordered pair is that intersects the lines. So that's this one right here. And that appears to be the ordered pair, 0, 3. Well, did we see that before? Again, some of you noticed way back here when I had this ordered pair that we had already seen it in the red equation. So those were matching back there, which means they were intersecting. And that would have been at the point 0, 3, which we've demonstrated here. So that's it. That's all we need for this one. Again, could we have found other values here? But yeah, we could have, but they would have been off the graph the moment we found like negative 6, or even if we went up to 9 for the purple graph. All right, as far as that last problem was, this one's going to be just a little different, but also very much the same. So this first one, I'm going to make my red equation. And we could change that into slope-intercept form, but again, it seems like most students are doing better with the input-output thing. So I'm going to make, for me, I will make a table. So I got x's and y's. It's going to give me a bunch of ordered pairs, like this. And the truth is, with this type, you may have to use some guess and test, meaning that some x values that you put in may not give you very nice y values. This one, it looks like it will, but I just can't guarantee that for sure on all the problems. So, as usual, I am going to choose an x value that's 0, but here's what happens to our equation. Is we have 3x plus y equals negative 5, but we've chosen to replace the x with 0, right? That's what we're putting into the function. Then we see what comes out. Well, that's going to be a 0 term, and we're just left with y equals negative 5, and so we end up with the ordered pair 0, negative 5. Now that one works very nice because we chose an x value that's 0. Here's something else I would try if I were you. I'd say, you know what, I'm just going to choose a y value that's 0 because of this setup that it is in. And that setup right there is called standard form, just like we saw in that last problem. But you'll see now that I've got 3x plus y equals negative 5. Actually, this one's not going to turn out very well for us, but sometimes it will. So you gotta check. Okay, so I've replaced the y with 0, and again, that's just a 0 term. I end up with 3x equals negative 5. That's not solved. I've got to use a principle of equality here by dividing both sides by 3 in order to show that x is negative 5/3. Now that's an x value. Could I put this on the graph? I could estimate, but I don't really want estimations because like 0, negative 5 there for us, that's a very clear ordered pair. But the thirds is what's going to throw us off on the graph. So I'm not actually going to plan on putting that on the graph, but we'll point it out once we get some other values. So I'm going to stick with just choosing x values. So we get 3x plus y equals negative 5. Again, it doesn't really matter which values you choose, but I like nice ones like 1. Okay, so I would replace the x there with 1 because 3 times 1 is just 3. 3 plus y equals negative 5. I can see with this, I can just subtract 3 from both sides, and then y would be negative 8. Boom. Okay, now the thing is, and I'm not going to show the work on this, so I'm going to skip a little bit, But if you chose a value that's 2, then what you would get is negative 11. Now I can't put that on the graph because the y value is negative 11 and my y value only goes to negative 10. So I'm going to skip that one, and just to save some time, I'm not going to show the work on it, which means I need to go in the other direction from 0 and make this negative 1. So what happens there? Well, you'd have 3x plus y equals negative 5, and we're now replacing the x with negative 1. So that'd be negative 3 plus y equals negative 5. And one principle of equality, just add 3 to both sides. You get y is negative 2. Okay, so that's an ordered pair. Yeah, I can put that on the graph, no problem. In fact, let's go a little bit further and make this an x value that's negative 2. So that's 3x plus y equals negative 5, but I can now replace the x with negative 2. Okay, so that's going to be negative 6 plus y equals negative 5. Principle of equality is going to add 6 to both sides. Zero that out, then y equals 1. So negative 2, 1. All right, now that's as much space as I have for my table. Let's see if that's enough. So I'm going to start at the top there. 0, negative 5 is here. Then I also had the ordered pair 1, negative 8. So 1, negative 8. Then we had negative 1, negative 2. Negative 2, 1. All right, now that's all the ordered pairs I can fit on the graph. Of course, we did have 2, negative 11, which would have been, somewhere down here. But I don't really care about that one because it's off the graph. Let's see what happens when I graph. We're going to call this our purple equation here. Y equals 1/2 x plus 2. But I'm going to use the same method where I'm going to make a table of x's and y's. I got values that I'm going to put into this function machine. See what happens. Okay, but as usual, I am going to start with an x value that is 0. So that would be y equals 1/2 x plus 2. But now we've just chosen to replace the x with 0. So that'd really just be 0 plus 2. That's a y value that's 2. So 0, 2. That's a good enough ordered pair. Okay, so next up, I'm going to choose an x value that's 1. I'm putting values in. Y equals 1/2 x plus 2. And I guess I should have noticed this, but if I replace the x with 1, it's going to give me a fractional value. That'd be 2.5 or like 2.5 as a decimal, which again, you could technically put on the graph, but it's not really going to help me out because of the decimal. That's why I should have noticed this already, but the denominator is 2. I should only choose multiples of 2 as my x value. So 2 would be a good, nice value to use next. Yeah, that y value is 2.5 there. But next up, we got y equals 1/2 x plus 2 again. But now I've chosen an x value that's 2, and this should work out much better. So y equals 1/2 times 2 plus 2 is going to be 3, 2, 3. And we'll try one more. Again, I'm going to choose an x value that's a multiple of 2, so I'm going to choose 4. See what happens there. There's our y equals 1/2 x plus 2. I'm replacing the x with 4. And looks like I'm going to get 4 out of that one. Okay. Now, before I continue, I'm going to show you what's happening here. So we have the ordered pair 0, 2. We have the ordered pair 2, 3. And we have the ordered pair 4, 4. What's happening is that as I put more points on my purple line, it's getting further away from the red line as I go to the right. In fact, without showing the work, we would have these ordered pairs on the purple line. Now, again, the reason I'm not showing those is because they're getting further away as I go from left to right from the red line, which is going down here. So putting those on the graph isn't going to help us out so much. But if I reverse direction and I say, you know what, I'm going to make my x a negative 2 instead, here's what happens. So we got y equals 1/2 x plus 2, and we just chose an x value that is negative 2, and that's okay. But my corresponding y value ends up being 1. Okay, so negative 2, 1. We've seen that before, actually, with the red ordered pair. We can see it right there, negative 2, 1. Now on the purple graph, I have negative 2, 1 also, which would give me this ordered pair, which I've already put in red. Okay, so this is my intersecting point at, it appears, negative 2, 1. Now, as much as you'd like, you could find these other values. I'm just going to put them on the graph so it looks nice. But this point would have been there, negative 4, 0, then negative 6, negative 1, negative 8, negative 2, and also negative 10, negative 3. You could have found these ordered pairs on your graph. It wouldn't have mattered. And then to expand the red one also, this one, looks like we would have been at negative 3, negative 4, negative 4, sorry, I said negative 4, negative 3, negative 4. It's negative 3, 4, then negative 4, 7, and then finally negative 5, 10. All these points would have been in your tables. But again, we've already found the ordered pair where the two lines intersect. So let's draw the lines. There we go. But we still have our ordered pair at the intersection because negative 2, 1 made both of these equations true statements, proving that it is the point of intersection on the graph. Okay, when we write equations, the basic form will be based on the information given, meaning that it's possible we could have an equation in slope-intercept form, which is y equals mx plus b, m being the slope and b being the y-intercept. Now, if you remember that, you could have been using that the whole time, but again, I'm sticking with this input-output stuff for us. The other type of equation we may see is called standard form, which we have seen. And that takes on this basic format, ax plus by equals c, and it doesn't really matter which one's in front of the x's or y's there. But if they give us some kind of rate, generally speaking, and this would include a rate and starting value, then we have a slope-intercept form. If they tell us that we have two total type values, then we end up usually writing stuff in standard form. Okay, now these are just general rules, so we may not see them exactly like this, but for the most part, that's the way it usually works. So a rate would be something per something else, right? Dollars per hour, miles per hour, something like that. So the variables should represent the two values you need, meaning they're going to say how many miles did they go, how many dollars did they spend. Okay, well now you know that the variables have to be represented that way by those two values. And then you know to solve for those two values. So make sure at the end as well, since we are dealing with word problems, that you label your answers. If you don't, it's likely you would lose credit if it were some kind of written test or quiz. But do keep in mind, there's no guarantees that these are all going to be exactly alike. You have to pay attention, which means while you're doing these problems, you may have to read and reread and reread and reread these problems 4, 5, 6, 7 times even to understand them, okay? Once you understand them, then it usually becomes a little bit easier to put them on a graph or even write the equations for them. So expect to take that time. I can't guarantee that they're all going to be very similar or even the same. But I still will do this example for us. So it says Caroline went to the grocery store and bought bottles of soda and bottles of juice. Each bottle of soda has 30 grams of sugar, and each bottle of juice has 15 grams of sugar. Caroline purchased a total of 6 bottles of juice and soda, which collectively contain 150 grams of sugar. Graphically solve a system of equations in order to determine the number of bottles of soda purchased, X, and the number of bottles of juice purchased, Y. So they're defining for us the X's and Y's. So even though the graph is not showing us the labels, we can put them on right now, because even right now they're saying, hey, look, the X, it's a number of sodas purchased there. So I'm just going to copy that down, put it down here. They told us what it was, okay? And then over here it says the number of bottles of juice purchased is Y. Now I'm just going to show that as bottles, number of bottles. In fact, I guess I will clarify that and call it bottles of juice. Yeah, what the heck. I'm just copying and pasting here, so I can take that and just kind of attach it there. There we go. Number of bottles of juice purchased, that's our Y axis, which is always the vertical axis. So that at least sets us up with the graph right there. So let's look at the information that's given and see if we can put this on the graph. Now I'm going to write the equations for this. I'm not sure that everyone needs them, but I'm still going to write them. And first up, in the reading process here, let's see if we can put these in some kind of colored format so we know what we're talking about. One of the parts I noticed here is that we're looking at 6 bottles of juice and soda. That should give us right there one equation based on the number of bottles. But then in addition to that, we should have another equation that's based off of, looks like grams of sugar, because the soda has 30 grams of sugar and the bottles of juice have 15 grams of sugar. So I'm going to write 2 equations, one in purple, which is based off of the grams of sugar, and then the second one is going to be my red one, which is based off the number of bottles purchased. So we're going to go off the sugar equation first, which says, and again, we've already defined our variables, so we are going to have y's and x's in here. In fact, I'll do x's and y's first. But the x's, which is number of sodas purchased, and soda is saying that you get 30 grams of sugar. So every bottle of sugar, every bottle of soda, which is X, is going to have 30 grams of sugar. So I have 30 grams of sugar times the number of bottles. That's how much sugar we get just from the bottles of soda. Then it says also that you have 15 grams of sugar for each bottle of juice, which is our Y's, right? That's what it's saying right here. So 15 grams for every bottle of juice. So again, this would indicate you got 15 grams for every bottle of juice. Multiply the 2 together. It tells you how much total sugar you get from the bottles of juice. Now, I would have to add these together to get the total amount of sugar that was in the 6 bottles, which it says was 150 grams. It says it right there. Right there. There we go. Now notice, what type of equation are we dealing with here? This is a standard form equation because it gave us totals. It gave us total amount of sugar and total number of bottles of juice and soda. But now that I have that, yeah, I'm still missing an equation, right? I still need an equation based off the number of bottles. So the number of bottles, you have bottles of soda, that's X. You have bottles of juice, Y. If you were to simply add these together, then you would get the total number of bottles purchased, which it says was 6. Now, those are my 2 equations. Let's go ahead and see if we can put this on the graph. So, well, get ourselves a nice table going here. X's and Y's. I'm going to need a little extra space there with these standard form equations, right? Because I'm going to have to use some principles of equality. But I definitely will still start with an X value that is 0. Okay, so if I say X is 0 here in my sugar equation, which is in purple, then it would have been 30X plus 15Y equals 150. But if I replace the X with 0 there, then I get a term that's 0. All I've got to do is solve this for Y by dividing both sides by 15. So that would be Y equals 10. So that would be the ordered pair, 0, 10, meaning if you get 150, grams of sugar? If you get 150 grams of sugar, then you could have bought 0 bottles of soda and 10 bottles of juice. But we know that's too many, right? It doesn't fit 6. We need a total of 6 in here. So I'm going to adjust this just a little bit. Okay, now 30 and 15 are related, so I'm going to say, you know what? Let's say that I bought 1 bottle of soda here. Okay, so what happens then? So in my equation, 30x plus 15y equals 150. I now know that I've purchased 1 bottle of soda. So what happens here? Well, that would be 30 plus 15y equals 150. That's going to work for us because subtract 30 from both sides says it's 15y equals 120, and then divide both sides by 15. And I can't do that in my head. I believe it's 8. Well, let's see. 120 divided by 15. Enter 8. Yep. So if we had purchased 1 bottle of soda, it would have given us 8 bottles of juice. Okay, all right, well, fair enough. What happens if I purchase 2 bottles of soda? Okay, well, that would have been, I know I've run out of space there, but it would have been 30 times 2 plus 15y equals 150. I have to skip some work on this one because I'm out of space there. But it looks like 90, 246, looks like that would have given us y value 6. Okay, now we're getting closer. You see we're getting 2 bottles closer at a time for our juice, but that's adding an X or a soda bottle. So this was 10 bottles, then 9, then 8. Remember, we're trying to get to 6 bottles over here. So I'm actually going to skip one of the values. I'm not going to do 3. If you did 3 in here, which you could do, you would have gotten 3 and 4. But again, that's 7 bottles. Now, I know then if I get 4 bottles of soda, then I should have 2 bottles of juice. But I'm going to prove it with the equation. So 30x plus 15y equals 150. Let's see if we can fit this in there anyways. Well, the x we've just chosen to replace with 4. So that'd be 120 plus 15y equals 150. And then would subtract 120 from both sides. So that's 15y equals 30. And then divide both sides by 15. And then we get y is 2. See that? So we get an ordered pair for 2, which we can then put on the graph. Now I'm going to stop there because I know that that's 6 bottles. I don't necessarily even need to solve this one, but it is asking for the graph, so I'm going to have to get some ordered pairs on there. But let's get the ones that we have there. So we got 0, 10. That's the y-intercept. We have 1, 8 here. 2, 6 there. 3, 4 here. And then 4, 2 there, which means that if you were just to purchase all soda bottles here, you'd get 5 of them, and that would equal 150 grams of sugar for that. All right, well, that is our purple line, and I'm going to wait to draw the line because I want to see what happens with our red equation, which is based on the number of bottles. This one's not so bad because it's just x plus y, but I can choose x and y values here. And just to make it nice and clean, I'm going to choose an x value first. That is 0. So that would be x plus y equals 6. But I'm choosing to replace the x with 0. And that really just tells us that y is 6. So that gives us an ordered pair 0, 6. Again, I'm going to wait to put that on the graph. But now that I have that, let's see what happens when I go up 1 bottle for my x. So that's a soda bottle plus a juice bottle, should be 6 bottles. But now I'm saying, well, how many juice bottles is it if I choose 1 soda bottle? Well, you can solve this for y, but you subtract 1 from both sides and get a y value of 5. So there's 5 juice bottles if you purchase 1 soda bottle. And again, we expect that because as I add these two numbers together, it has to equal 6, right? It has to be 6 total bottles no matter what. And continuing here, I would say, well, what happens with 2 bottles? Well, that would have been x plus y equals 6. But now the x is 2. So we would subtract 2 from both sides and get y equals 4. Okay, so that's 2 soda bottles, 4 juice bottles. Okay, let us continue here. What happens when we get 3 of these soda bottles? So the equation would be x plus y equals 6. But now we're replacing with x with 3. So to solve this, we would subtract 3 from both sides. Y is 3. So 3, 3. I'll give myself an extra blank there. So next, we'll see what happens when we get 4 soda bottles. Well, it's x plus y equals 6. Replace the x with 4. And then solve. So minus 4 from both sides. And we get y is 2. So 4 soda bottles, 2 juice bottles. And that would be an ordered pair. Now at this point, some of you may notice something, and that's okay if you do. I'm going to skip the rest of this. I will say that if you had 5 soda bottles, you'd have 1 juice bottle. But also if you had 6 soda bottles, you'd have no juice bottles. So that gives us these ordered pairs. We got one at 0, 6, 1, 5, 2, 4, 3, 3, 4, 2, which is already on the graph in purple, so I'm just going to circle it, 5, 1, and then again it just goes down another bottle there, 6, 6. Now I think I said, I may have said that I was going to put line on the graph. I'm not going to, and here's why. This graph right here, this goes back to Unit 5. This is a discrete graph. Now, some people would say it's discrete because you put the points on it, but if you draw lines down here, then it's continuous. Here's why it is discrete no matter what you're thinking of here. It's because these are bottles of soda purchased. If I connect points, then it says that you'd have values in the middle as well, which would give me fractional bottles of not just soda, but juice as well. And since I can't have fractional values of soda bottles and juice bottles, I have to keep these as just points on the graph. Okay, so these graphs are going to stay discrete, and I can point out the point of intersection here where it's both red and purple right here, and that was at 4, 2. Okay, but again, what does that represent? Well, it's 4 soda bottles, 4 sodas, and 2 juices. That's what I'm going to put on there, just because it's a lot easier to put on. But that's it right there. That's all we really need on there. Maybe the ordered pair, they may have you actually state what they are, 4 sodas, 2 juices. Doesn't matter. That is the graph, and this is our solution. Okay, now, just to remind you, if you want to change these into slope-intercept form, you can. But we have to force it to be in slope-intercept form with principles of equality, making zeros and ones as we go. So I'll demonstrate that on this next problem. This is in standard form, ax plus by equals c. But to change this into slope-intercept form, okay, so slope-intercept form, I'll put this down here. That would be y equals mx plus b, where m right here is our slope, and the plus b part is our y-intercept. Okay, right now the equation is not in slope-intercept form, but we do want it there. So the first thing we would do is isolate the y's. We're really solving for y. So the 2x has to go, meaning we're going to have to subtract 2x. And that's going to zero that out. I can then drop my 3y's, which now equals, these two are not like terms that I can combine, but I still put the negative 2x there just so I can put it in front. And then we got the positive 12. Now this is pretty close to slope-intercept form. The only difference is this is a phantom 1 and this is a 3. So to change that into slope-intercept form, I will divide all the terms by 3, which would leave me with just 1y equals, that's going to be a negative 2/3 x, and then 12 divided by 3 would be positive 4. And this right here is our slope-intercept form. So could you use this to graph? Yeah, you got your y-intercept and you got your slope. So you could put all the points on there. You wouldn't need the tables like I'm using, but again, I'm using the tables because it seems like most students are struggling with this slope-intercept form. At least they did during Unit 2. If that's changed, which it could have, then you may be able to take the shortcut of using slope-intercept form, but that's up to you. Okay, so there's our objectives. We should be able to solve a system of equations with graphs, and then also we should be able to write the equation from word problems, but we should also be able to change standard form into slope-intercept form, just if we need to. But in addition to that, we will on the assignment, so just expect that. There's going to be a couple problems where they're going to say, here's standard form, change it to slope-intercept form. So we're going to have to do that one way or the other. But again, the graphing seems to work better with the tables. All right, the rest of the period is yours to actually do the assignment, graph the equations, figure out your point of intersection, and then call it good.